So, in today's lesson, we are going to look at factor theorem and the polynomial. So, we are going to look at factor theorem and the polynomials. Factor theorem. So, when we talk about factor theorem, we are just looking at the values, or we are talking about values of a certain number, or values which will divide a certain function, or divide a certain number that will leave a remainder of 0. So for instance, in our daily life, we have been doing this. Let's say we have 16, or let's say 16 oranges divided by 2. So let's say if you have 16 oranges and 2 people are to share, it will leave, everybody will get 8, remainder what? 0. Meaning this 2 here is a factor of 16, because when you use these 2 to divide the 16 here, we get what? Everybody is going to get what? 8, and the remainder is going to be what? 2. So for instance, if they said find a factor of a certain number, they are just talking about the values which, when you use to divide that particular number, that will give you an answer, but the remainder will be what? 0. So let's say if you are to find the factors of 16, therefore we are going to get 1, which is a factor of 16, because if you have 16 oranges and one person is, you have to divide that 16 by 1, the person will still get this, or the whole item. Let's another factor is 2, because we have 16 oranges and 2 people are going to, everybody is going to get 8 without a remainder. So we have with the value 4, which you can mention them 8, then the 16 is saved. So these are the factors of what? 6. Meaning if you take this, any of these values here, if you take any of these values here and you use to divide this number, this 16 here, it will give you an answer, but the remainder was 0. So let's say, so the same idea that we are using, or we are applying over here, when we talk about the factor theorem, all that we are saying is that if you have a certain function, let's say f of, let's say, a certain value a, and is giving you an answer of 0, meaning that this a here, or this value here, or this variable here, is a factor of this function, because when you substitute, or if you use this value here to divide the function, it leaves a remainder of what? 0. So for instance, if we have the function f of k to be equal to 0, what that we are saying is that the k is the what? A factor of what? The function here, because when you use this k to divide the function, it will give you a remainder of what? 0. So for instance, so normally if we have and also algebraically, or the polynomial wise, polynomial function is consist of what? Algebraic what? Expression. So let's say you may have a function like f of x, so f of x being equals, let's say, x squared minus s plus 3, and you said f of k is a factor of this function, meaning when you substitute in place of what x, if you substitute the value of k inside, the whole function will go to 0. Meaning it is telling you that the k here becomes the what, a factor of this function. So for instance, if x minus k is a factor of the function f of x, meaning that if x minus k is a factor of the function f of x, meaning that when you substitute the value, or if you substitute this factor into this function, everything will go towards 0. So before then, because the function is made of what the variable x, so you have to make the factor here as the subject because everything will go to 0 by what, setting the factor here to be equal to 0, then find for the value of what, x, then substitute the value of x inside the function. So all that I'm trying to say that if this is the function here, because the function is made of the variable s, so you have to make s the subject. So by setting this factor to be equal to 0, then make s the subject, which you are going to get s is equal to k. Meaning that if you have the function f of x, meaning that in place of s, we can put what, k there. So let's take one practical example and see. So first of all, show. So example 1. Show that x minus 2 is a factor of x cubed minus 4x squared, x cubed minus 4x squared plus 3x plus 2. Good. According to the question, they said we should show that x minus 2 is a factor of what? The function. So a function x cubed minus 4x squared plus 3x plus 2. So meaning that if you put this value here, this factor here, if you use to divide the function here, everything, the remainder should be what, 0. Meaning that first of all, the first thing to say, you have to label or you have to define the function. So you say maybe let f of x to be equal to the function we have here, because this is a function. So we have x cubed minus 4x squared plus 3x plus 2. Then from here, this is the factor. So in the function here is made of the variable s, meaning that we have to make s the subject here. And wherever we see s, you put the value of what, s there. So we are going to get x minus 2 to be equal to 0. Therefore, x is equal to what? 2. Therefore, in place of the x, you can put what, 2 there. So therefore, the function is going to be f of 2, which is going to be what? 2 to the power cube minus 4 times 2 to the squared plus 3 times what, 2 plus what, 2. So 2 cube is going to give you 8. 2 square will give you 4. 4 times negative 4 is going to give you negative 16. Then 3 times 2 is going to give you what? 6 plus 2. Therefore, 2 plus 6 is going to give you 8. 8 plus 8 is 16. 16 minus 16 is going to be 0. So which is telling you that x minus 2 is a factor of what? This function. Because after substituting the value of what? X into the function, we had a value of 0. You can also refer to the long division method. You can also use the long division method also to check or to divide. You can use the factor here to divide the function. In my previous lesson, and after using the factor to divide the function, if we had the remainder to be 0, then it is telling that x minus 2 is a factor. So let's take one more example and try. We show that x minus 1 is a factor of the function f of x equal to x to the power 3 minus x squared plus x plus 1. So you can solve it on your own. Thank you, and subscribe to my channel for more content. Bye.